Hello everyone, welcome to the fourth video of our lecture series. So in this video we will again discuss some more problems on quantum mechanics. So this is the first problem so we are going to solve today. So what the problem states? It states that we have a spin half particle and it is in the state psi which is given. So this is the initial state of the spin half particle, and now if Sx, that means the x component of the spin angular momentum operator, is measured, then what is the probability of getting h cut by 2? So the question states that we have a spinor particle in a definite state and we measure the x component of spin angular momentum, then what is the probability then that we will get the result h cut by 2? So let us solve this problem. Okay, so the given state is psi, which is 1 over root 6 1 plus I by 2. So first of all, before proceeding with any quantum mechanical problem, first you have to ensure that the given state is normalized. So just check that. So if the wave function is normalized, then this should be 1. So let us check. So get psi is 1 over root 6 1 minus I 2. So psi it will give us 1 over 6, and if we do the matrix multiplication we will get 1 minus I square plus 4. So this is 1. So this is perfectly fine. The given state is normalized, so we don't have to do any more normalization or something. It is already normalized. So now we know that for a spin half particle, Sx is given in the matrix form as h cut by 2 0 1 1 0. So it is in the Sz and S square and Sz basis. So we have the matrix formula of Sx, and so first of all we have to find its eigenvalue, because we have to find the probability of getting h cut by 2. So let us check if it is eigenvalue of its or not. So what is the procedure for calculating eigenvalue? So if lambda is the eigenvalue of Sx, then we will have this. So h cut by 2, sorry, this will not be h cut by 2, this will be minus lambda. This is h cut by 2, this is h cut by 2, and this is minus lambda. So we will have lambda square, which is h cut by 2 whole squared. So we will get eigenvalue plus minus lambda h cut by 2. So now let us calculate the eigenvector. So for lambda h cut by 2, if the eigenvector is AB, then we will have 0 h cut by 2, this will be h cut by 2, and this will be 0. So if the eigenvector is AB, then we will have h cut by 2 AB. So from here we are getting, from the first line we are getting h cut by 2 B is equal to h cut by 2 A. So we are getting A is equal to B. So A and B we can take any value, but let us since we know that eigenstates are normalized, so we have to ensure that a square plus b square, this value should be 1. So if both are same, so we can take a and b to be 1 by root 2. So that is the eigenstate. So the eigenstate is a by root 2 1 1. So we are getting the eigenstate a 1 by root 2 1 1 for eigenvalue h cut by 2. So let us denote this by 1. So we have to find the probability of getting h cut by 2. So we can express this wave function psi as a linear combination of 1 and 2, because since 1 and 2 they form a basis, so we can expand any wave function in terms of these two. So 1 is the eigenstate of h cut by 2, and what is 2? So so 2 is the eigenstate for minus h cut by 2. So we have to find the probability of getting h cut by 2. That means we have to find mod square of alpha. So how can you do that? So if we multiply this by ket 1, so since the eigen vectors are normalized, that you can check, right? Like you can calculate the eigenstate for this eigenvalue, and you will get this 2, and this term will be 0. So from here we can calculate alpha to be 1 psi, and 1 is given as 1 by root 2 1 1, and our psi is 1 by root 6 1 plus I by 2. So if we do the calculation, we will have 1 by root 12 1 plus I plus 2. So that means 1 by root 12 3 plus I. So what will be mod alpha squared? So it will be alpha star alpha, and alpha star will be complex conjugate of this number. So it will be 3 minus I, and we will have 1 by root 12 3 plus I. So this will give us 1 by 12 multiplied with 9 plus 1. So it will give us 5 by 6. So let us check. Yeah. So this is the correct answer. That means if we measure Sx, then the probability of getting h cut by 2 is 5 by 6. Okay, now move to the second problem of this video. So this is the problem. So it states that we have an operator and we have to find its equivalent form. So basically these questions are pretty straightforward, but there is always a chance of mistake. So what is the mistake here? Because while doing this kind of problem, so what generally people do is like, so here it is the operator. So to find the equivalent form, some people can just multiply this, and if we do just this, then it will be ddx of x ddx minus x square. So it will comes out to be so this can happen, but this is not the correct way of proceeding. So what is the correct way of proceeding of doing this kind of problem? Like you can be given any kind of operator. So what you have to do, so you have what does the operator do? So basically operator, it operates on a function. So that is the first thing you have to do. You have to assume a function and then operate on that. Otherwise what you will do will be wrong. So suppose we have a function f of x. So what we will do, we will operate this operator on the function. So let us do that. So generally operators do not commute. So what does that mean? That means we cannot always write AB as BA. So basically this is not true in general. So that is why you have to first operate this on f of x. So what we will get? So we will get ddx plus x f of x. So we will have df dx plus x of f. And now we have to operate the first term on this. So what we will get? So we will get ddx d2x dx square plus ddx of xf minus x df dx minus x square f. So let us do that. So we will get ddx d2x dx square plus, from this term we will get f df dx plus f into dx dx minus f df dx minus x square f. So this term and this term will be cancelled out. So we are left with d2f dx square plus f minus x square f. So if we take f common, we will have d2 dx square minus x square plus 1 into f. So what we are getting? We are operating this term, we are operating this operator. So this is our operator on f of x, and we are getting this. So basically these two may look different, but if you add these two operator on a function, it will produce the same result. And that is why these two operators are equivalent. So equivalent means that they are not same, but if you operate that on a function, it will give us the same result. So in that sense they are equivalent. So our correct option is B. So this is our answer. So in that way you can do like this similar kind of problem for any operator. First you have to just assume a function, and you will operate on that and do some basic algebraic manipulation, and you will get our desired answer. Okay, so that is our second problem. Now let us move to the third problem of our this video. So this problem states that we have a three-state system, and its energy eigenstates with its corresponding eigenvalues are given, and the initial state of the system is also given. So we have to find out the probability that at a later time, say t, so the system will be in this state. So what is the probability of the system at a time, after a time t, to be in that state? So that we have to find out. So let us proceed. So what we will generally do? So we have to so this is our initial state. So in what will be the approach? So this is our initial state, and we have to find its time evolution. So what is the easiest way to find time evolution? We have our energy eigenstates given with its energy eigenvalue. So suppose we have a state psi and we have energy eigenstates phi n with corresponding eigenvalues En. So if we can express that psi in terms of Cn phi n, then psi at a later time can be written as Cn e to the power minus I E n t by h cut into phi n. So this is in that way we can find time evolution of any state. So here we have our energy eigenstates and we also have our energy eigenvalues. So what we will have to do? We will first have to find these coefficients. So let us proceed. So we can write that psi initial to be alpha phi 1 plus beta psi 2 and gamma psi 3, where we have our psi 1 as 1 by root 2 1 minus 1 0. We have psi 2 as 1 by root 6 1 1 minus 2, and we have our psi 3 to be 1 by root 3 1 1 1. So it is always healthy to check if the states are orthonormalized or not. So for orthonormalization, first we have to ensure that psi 1 is 1. So let us check. So it will have this and 1 plus 1, so that is 1. Similarly, you can check that these are orthonormal. So this is also 1. Similarly, we can do psi 3 and it will give us, that is also 1. And we can check psi 2 psi 1 to be 1 by root 12 1 1 minus 2 and 1 minus 1 0. So this will be 0. And psi 2 psi 3, this will give us 1 over root 18 1 1 minus 2, and we have 1 1 1. So we will get 1 plus 1 minus 2, so that will also be 0. And last one is psi 1 psi 3. So it will give us 1 over root 6, and we will have 1 minus 1 0 and 1 1 1. So this is also 0. So this states psi 1 psi 2 psi 3, they are orthonormal. So it is always healthy to check if they are orthonormal or not, so because it will take very less time. So now it is easy to find these coefficients. So how we can find these coefficients? So first multiply this with this expression with get psi 1. So if we do that, what we will get? Psi 1 will be 1, and psi 1 psi 2 and psi 1 psi 3, they will be 0. So we have in the right hand side alpha. So alpha we can get as, so we have our psi 1 to be 1 over root 2 1 minus 1 0, and we have our initial state to be 1 0 0. So it will give us 1 over root 2. Similarly, for beta, we will multiply this by ket psi 2, and we will have 1 over root 6. Here we will have 1 1 minus 2 and 1 0 0. So that will give us 1 over root 6. And gamma, we will get this as psi 3 psi I. So that will be 1 over root 3 1 1 1, and we have here 1 0 0. So that is 1 by root 3. So we can write psi I as 1 over root 2 psi 1 plus 1 over root 6 psi 2 plus 1 over root 3 psi 3. So this is at time t equal to 0. So what will be the state after time at a later time t? Now this has eigenvalue E, this also has eigenvalue E, and this has eigenvalue E minus 3g. So let me just confirm this. So E and 3g with psi 1, psi 2 and psi 3. Fine. So what will be its the state after a time t? So after a time t, the state will be 1 over root 2 e to the power minus e t I by h cut psi 1 plus 1 over root 6 e to the power minus I e t by h cut psi 2 plus 1 over root 3 e to the power minus I e minus 3g t h cut multiplied by psi 3. So this is our state at a later time. So we have to find that what is the probability that after time t system will be in this state. So psi f is 0 0 1. So we have to find the what is the probability of collapsing this state into this. So what is the probability? The probability will be psi f psi I t is mod value squared. So let us do this calculation. So we have our psi f to be 0 0 1, and we have our psi initial to be, so 1 by root 1 by 2 minus 1 by 2 0 e to the power I e t by h cut plus 1 by 6 minus 1/3 e to the power I e t by h cut. So let us write this, these are minus, and we have again also 1/3 e to the power minus I e minus 3g t by h cut. So this is our psi initial, and we have to find its mod value. So what will be the answer? So for first multiplication, we will get, for this term it will be 0, this product will be 0, and this product will be 0. So from the first matrix multiplication we will get nothing, and for the second one we will have 0 multiplied by 1 by 6. So let me write down this I e t by h cut, and for the last one we will get 1/3 e to the power minus I e minus 3g t by h cut. It's mod value squared. So what we will get? We will get 1 by 9 e to the power. So just let me do the calculation. There are nothing, and like not anything more. You have to just find this value. So we have to find the product of this, and what will be the value. So we will have 1 9. So first term, this term will be 1, and this product will also be 1, and we will have e to the power I minus 3I gt by h cut, and also we will have e to the power I 3 gt by h cut. So if we take 2 out, so we will have this, so e to the power 3I gt h cut plus e to the power minus 3I gt by h cut by 2. Okay, so I think I have done a mistake. So yeah, there should be a minus sign. Yeah, so for this one we will have a minus. So we will get this, and these two terms will be minus, and it will also be minus. Sorry for the calculation mistake. So we will get 2 by 9 1 minus cosine of 3I gt by h cut. I will not be there. 3 gt by h cut. Now we know that 1 minus cos theta can be written as 2 sine squared theta by 2. This is standard trigonometric result. So from this we can write 4 by 9 sine squared 3 gt by 2 h cut. So this should be our answer. So let us just check if it is in the given question or not. 4 by 9 sine square, yeah, so this one. So this is our correct answer. So that type of problem we have also previously done in previous videos. So the concept is similar, like you are given energy eigenstates. So if you if you have to find the state at any later time, so it is always useful to express our initial state as a linear combination of our energy eigenstates. So from that way you can easily find its time evolution, and whatever will be the final state of collapsing, you have to just do just some mathematics and it will be done. So now let's move to the fourth problem. So in the problem we are given a potential, a two-dimensional potential, and we have to just find the energy of the first excited quantum state of the particle. So first of all we have to find the energy of, so we have to write down its Hamiltonian. So let us write down the Hamiltonian. So what will be the Hamiltonian? It will be, so since this is two-dimensional, so in Cartesian, and potential is also given in Cartesian coordinate, so we will write px and py. So this will be our kinetic energy term, and our potential energy term is half m omega squared x squared plus 4y squared. So let us just write this in a nicer way. So it will be plus half m omega squared x squared, and another term will be py squared by 2m plus half m 2 omega squared y squared as this. So why I am writing this as 2 omega? So you can now see clearly. So this is our 1D harmonic oscillator potential, and it has frequency omega, and this is also a 1D harmonic oscillator, but this has natural frequency 2 omega. So what will be the energy for this harmonic oscillator? The energy will be, energy of nth state will be h cut omega n, let us denote this by nx plus half, and energy of this harmonic oscillator will be h cut into 2 omega, since the natural frequency is 2 omega, and it will be ny plus half. So what will be the total energy? Total energy will be the summation of these two, exn plus yn. So we can write this as h cut omega, we have our nx plus 2ny, and we will have 3 by 2. So we have to find the energy of the first excited state. So first let us find the energy of the ground state. So for ground state, what we have? We have nx and ny to be 0, and that energy will be h cut omega 3 by 2. Now for first excited state, we have two choice. So we can make nx1 ny0 and nx0 ny1. So for that case, what will be the energy? It will be h cut omega. If nx is 1, we will have 5 by 2, and if ny is 1, then we will have 7 by 2. But in this two, this term is lesser than this. So this must be the corresponding quantum number for first excited state. This can't be the quantum number for first excited state, because we have for a different set of quantum number, we have an energy value which is lesser than this, and which is greater than our ground state. So that value corresponding to the first excited state must be. So that is why for first excited state we have nx1 and ny0. So similarly, this is our second excited state, and now we can check for different combinations of these two. Like you can check for nx1, ny1, and this one to be 1 and ny to be 2, and all these combinations, and you can arrange them arrange the order of the quantum numbers for which the state will be first excited or second excited or third excited, and so on. So there is not symmetry in the energy value, because the natural frequency of oscillation is different for these two harmonic oscillator. Like for two different dimension. In in x dimension, we have this natural frequency omega, and in y coordinate we have this natural frequency to be 2 omega. So in that way, like various kinds of problem can appear. So it can be like 9y square or something. So what you have to do, you have to just write down the harmonic oscillator potential, and then you can arrange and check for which quantum number you have which energy. So that is it for today's video. So we will meet on our next video.